Look up on almost any clear day, and the first thing you notice is something so familiar that most of us stop noticing it at all. Above the roads, the buildings, the mountains, the rooftops, the trees, and moving lives of millions of people, there is a vast ceiling of blue. It feels permanent. It feels natural. It feels so obvious that it almost never occurs to us to questioning it. And yet, if we pause for even a moment, the question becomes strangely powerful. Why is the sky blue? Not white, not silver, not black, not violet, not green, blue. This is one of those questions that belongs to everyone. A child can ask it, a poet can wonder about it, a physicist can spend a lifetime explaining. And still, even after the science is understood, the question keeps some of its magic. Because hidden inside that simple color is a story about light, air, space, motion, distance, and the fragile layer of the atmosphere that makes Earth feel like home. The sky does not really have a color in the way a painted wall has a color. It is not a solid object. It is not a dome stretched above the planet. It is not a giant blue surface hovering over our heads. What we call the sky is, in many ways, our experience of looking through the atmosphere while sunlight is passing through it. The blue we see is not painted there. It is created, moment by moment, by a conversation between sunlight and air. And that means the color of the sky is not just about beauty, it is evidence. It is a visible sign that something is happening all around us, all the time. Every morning, sunlight enters Earth's atmosphere after traveling roughly 150 million kilometers from the sun. It arrives at astonishing speed. It pours over oceans, crosses deserts, touches ice, glass, smoke, leaves, rivers, birds, cities, and faces. But before it reaches our eyes, it encounters something most of us rarely think about: the invisible ocean of gases surrounding our planet. That invisible ocean is not empty, it is alive with motion. Molecules are moving, colliding, drifting, vibrating. Dirt floats through it, water droplets gather inside it. Tiny particles rises from fires, salt, pollen, and soil. And when sunlight enters the sifting sea of matter, it does not simply pass through untouched. Some of it is redirected, some of it is scattered, some of it continues forward, some of it spreads out in many directions, and the sky we see is born from that scattering. But if that is true, another question appears immediately. To understand why the sky is blue, we have to understand what sunlight really is, what air really is, and what happens when they meet. We have to move from the familiar world of looking up to the invisible world of particles and waves. We have to follow light from the sun to earth, and then from the atmosphere into the human eye. We have to see how a color that seems calm and obvious is actually the result of constant activity too small to notice directly. This is also a story about perspective, because the sky does not only reveal the nature of sunlight, it reveals the nature of Earth itself. Our atmosphere is thin, delicate, and easy taken for granted. From the ground, it feels endless. From the space, it looks like a fractal veil hugging the planet. That thin layer protects life from extreme temperatures, harmful radiation, and the emptiness beyond. It carries weather, wind, clouds, rain, and breathe. It is the reason birds can fly, sound can travel, and blue can fill the day. Without an atmosphere, there would still be sunlight, but there would be no blue sky as we know it, and that means the color above it is not merely decoration, it is proof that we live inside a living system. Proof that Earth is not just a rock in space, but a world wrapped in air, movement, and light. So in this journey, we are going to begin where every human being begins, with the simple act of looking up. Then we will move deeper into the nature of sunlight, into the structure of the atmosphere, into the scattering of light, into the reason why sky turns red at evening and black at night, into the way clouds, dust, water, and pollution can transform what we see, and finally, into the deeper meaning of that blue overhead, not as a fact to memorize, but as a daily miracle to notice. Because sometimes the most extraordinary truths are hidden inside the most ordinary sights, and few sights are more ordinary or more extraordinary than the blue sky. To understand the color of the sky, we first need to understand the light that creates it. At first glance, sunlight seems simple. It shines, it brightens the world, it makes colors visible, and it feels warm on skin, it casts shadows, it moves across floors and walls, it wakes landscapes on its cities. It looks so natural that we easily forget how strange it really is. Because sunlight is not just brightness, it is energy traveling across space. It is radiation from a star. It is a stream of electromagnetic waves arriving from millions of kilometers away. And what our eyes call white sunlight is not truly one color at all. It is a combination of many colors packed together. When light is split by prims, by water droplets, or by certain atmospheric conditions, we can see some of those colors spread out into a spectrum. Red, orange, yellow, green, blue, indigo, violet. The familiar order of the rainbow is not something created by the prims or the raindrop. Those colors were already present in the light. The prims merely separates them so our eyes can distinguish them. So when we say sunlight is white, what we really mean is that sunlight contains a broad mixture of visible wavelengths that our eyes interpret together as white. That word matters, wavelengths. Visible light is only a small part of the full electromagnetic spectrum, but even within the visible range, different colors correspond to different wavelengths. Red light has longer wavelengths. Blue and violet light have shorter wavelengths. They all travel at the speed of light in a vacuum. but they differ in how frequently their waves oscillate and how they interact with matter. And that difference is crucial because the atmosphere does not respond to all wavelengths equally. But before we get there, it has to slow down and think about color itself. The sun, in reality, emits a wide range of radiation. Much of it is invisible to us. Beyond the visible colors are ultraviolet, infrared, and many other forms of electromagnetic radiation. Human vision occupies only a narrow band. Our eyes do not see the whole message of sunlight, only a selected portion of it. The sky we know is, in that sense, both real and limited. It is shaped by the world and by the way human beings are built to perceive it. If you were a different kind of creature with different visual receptors, the sky might not feel exactly the same. Even the sun itself can be misleading to our eyes. We often describe sunlight as yellow to observe on the ground. But outside the filtering effects of the atmosphere, sunlight is closer to white, near the horizon. The sun may look orange or red. Through haze, smoke, or dust, it may appear deeper and warmer. Yet those changes do not mean the sun itself is changing color in any dramatic way. What changes is the path the light takes through Earth's atmosphere before reaching us. This is why the sky's color is not a separate mystery from the sun's appearance. The two are linked. When the atmosphere scatters shorter wavelengths more strongly across the sky, the direct sunlight left traveling in a straight line toward our eyes becomes richer in longer wavelengths, especially near sunrise and sunset. The blue that spread through the sky helps create the reds and oranges of evening light. In other words, the same process that paints the daytime sky blue also paints the horizon red. That is one of the most elegant things about nature. The explanation is not a collection of unrelated facts. It is a single process creating many different visual experiences. Before we can explain that fully, we need to look at the second half of the encoder, not the light now, but the medium through which it travels. Because if sunlight is the message, the atmosphere is the instrument that changes how we receive it. And that instrument is far more active, layered, and alive than it first appears. If sunlight is only half of the story, the other half is the atmosphere, the layer of gas surrounding Earth that is so familiar we almost never see it as an object in its own right. Air feels empty, but it's not empty. We move through it constantly. We breathe it without effort. It presses against our skin, fills our lungs, carries skins, lifts birds, turns windmills, shapes weather, and bends sound. But because it is mostly transparent, it disappears from daily awareness. We notice it when it becomes dramatic. When wind rises, when fog thickens, when storms gather, when heat simmers, when the smoke hangs low. Even on a clear, quiet day, the atmosphere is present in immense quantity of all around it. What we call the sky is, in part, our view through this enormous transparent ocean of gas. Earth's atmosphere is made mostly of nitrogen and oxygen, along with smaller amounts of argon, carbon dioxide, water vapor, and trace gases. Tiny particles float within it. Dust, pollen, salt from the sea, soot from fires, droplets of water, microplastic pollutants, ash, and other aerosols. None of these things remain perfectly still. The atmosphere is dynamic. It circulates, it turns, it rises and sinks, it warms and cools, it holds clouds and storms, and it carries the conditions that determine how light behaves overhead. The electric and magnetic fields of light interact with the charge structure of atoms and molecules. Those molecules can absorb and re-emit some energy, or redirect light in ways that depend on wavelength and particle size. The result, on a large scale, is scattering. Light being sent off in multiple directions instead of continuing purely straight ahead. Scattering is the reason the atmosphere becomes visible at all. If Earth has no atmosphere, then even in full daylight the sky would not appear blue overhead. The sun would shine intensely, but the sky away from the sun would look dark, almost black, because there would be no molecules in the air to scatter sunlight across the dome of vision. The moon provides a powerful comparison. Under sunlight, the lunar surface can be brilliantly lit, but the sky above it remains black because the moon has essentially no substantial atmosphere to scatter light. So the blue sky is not the default state of daylight. It is a special effect of having an atmosphere, and not just an atmosphere made of molecules small enough to interact with visible light in a particular way. That is where scale becomes important. Not all particles scatter light in the same manner. Tiny molecules such as nitrogen and oxygen affect shorter wavelengths more strongly. Larger particles like water droplets in clouds or heavier aerosol in haze scatter light differently and often more evenly across the visible spectrum. That is why clouds tend to look white or gray rather than blue, and white dusty or polluted skies can appear pale, milky, or washed out. A clear blue sky is not simply a result of having air, it is the result of relatively clean air, sunlight, molecular scattering, and a viewing angle that lets those scattered wavelengths reach our eyes. There is another reason the atmosphere matters: depth. When we look upward, we're not seeing a surface, we're looking through a great thickness of air. The depth changes depending on the direction we look. Straight overhead, sunlight and our line of sight pass through less atmosphere than they do near the horizon. Toward the horizon, the path through the air becomes much longer and more scattering. More haze, more particles can influence the light. This is one reason why the sky often appears richer and darker above it, while nearer the horizon, it can fade into a paler blue or even a whitish glow. So when we look up the sky, we're never seeing some fixed background or color. We're seeing a real-time portrait of the atmosphere current state. It is a portrait painted in light. And at the smallest scale, the artists are molecules, countless invisible molecules interacting with sunlight in ways so delicate and so continuous that the entire sky becomes the canvas. To understand why that canvas becomes blue rather than any other color, we now have to move into the most famous part of the explanation, the kind of scattering that favors shorter wavelengths. That is the point where invisible physics become visible beauty. Now we arrive at the central mechanism. When sunlight enters Earth's atmosphere, the tiny molecules in the air scatter shorter wavelengths of visible light more strongly than longer wavelengths. This effect is known as Rayleigh scattering, named after the physicist Lord Rayleigh, who described it mathematically in the 19th century. You do not need the equations to understand the beauty of it. What matters is the pattern. Shorter wavelengths are scattered much more efficiently than longer ones. Blue light has shorter wavelengths than red light. Violet is shorter still. That means when sunlight passes through the atmosphere, the blue and violet wavelengths are redirected in many directions far more than red and orange wavelengths are. Since our eyes receive that scattered blue light from all around the sky appears blue. First, sunlight does contain violet, but there is less of it in the visible spectrum reaching us compared with some other wavelengths. Second, human eyes are not equally sensitive to all colors. Our vision is much more responsive to blue light than to violet light, especially under normal daytime conditions. Third, some of the shorter wavelengths light at the violet end is affected by absorption processes in the atmosphere. The result is that although violet end is scattered strongly, the combined experience reaching our eyes is dominated by blue. So the sky is blue not because violet is absent, but because the blue becomes strongest visible impression, and thus impression changes with conditions. On a very clear, dry day, especially in clean air far from pollution, the sky can look intensely saturated overhead. In heavy humidity, haze, smoke, or pollution, the blue can fade toward white because larger particles begin to scatter light more broadly across the spectrum. This is not the same kind of scattering that favors short wavelengths so strongly. Instead, it tends to wash colors together, making the sky look milky or pale. That is why not all blue skies are equally blue. It is also why the sky overhead is often a deeper blue than the sky near the horizon. When you look near the horizon, your line of dry light travels through much more atmosphere. Along a longer path, light encounters more molecules, more aerosols, more water vapor, and more opportunities for scattering of all kinds. The result can be a brighter, pale, hazier appearance overhead. Where you're looking through less air, the scattered blue may appear cleaner and richer. There is a subtle elegance here. We often imagine the sky as a single object with a single color, but in reality, every part of the sky is a different answer to the same physical process. Light from one region of the sky has traveled a slightly different path, encountered a different density of air, and reach our eyes from a different direction. The sky is not painted once, it is constantly being generated everywhere at once. Rayleigh scattering also helps explain why polarizing sunglasses can alter the appearance of parts of the sky. Scattered light can be partially polarized, depending on the geometry of the sun, the atmosphere, and the observer. That is why certain angles in the sky may darken more noticeably when viewed through polarized lenses. It is another reminder that a blue sky is not a flat backdrop. It is structured light, and because it is structured light, it can teach us things. Pilots, photographers, scientists, and skywatchers learn to read the sky not only aesthetically, but physically. A washed-out sky suggests moisture, haze, or pollution. A sharply saturated sky may hint at clean, dry air. A sudden change in clarity can signal shifting conditions. The atmosphere reviews itself through the equality of the blue. It is not a random color, it is the visible signature of an invisible interaction. And once you understand that, the sky becomes harder to take for granted. The next clear day no longer feels like simple blankness overhead. It feels like evidence of something constantly happening above every road, ocean, field, and city on Earth, the endless redirection of sunlight by air. But the story does not end with blue. In fact, some of the most dramatic sky colors appear when blue begins to disappear from direct paths of sunlight. That is when evening arrives. That is when the atmosphere stressed the journey of light. That is when red, orange, gold, and pink begin to dominate. The same physics that makes noon blue also makes sunset burn. If you want to see the atmosphere revealing itself dramatically, watch the sky when the sun is low. At noon, sunlight comes down through a relatively shorter path in the atmosphere before reaching our eyes. But near sunrise and sunset, the geometry changes. The sun is close to the horizon, and its light has to travel through much more atmosphere to reach it. The longer journey transforms the color of the light. As sunlight passes through this extended path, shorter wavelengths, especially blue and violet, are scattered out of the direct beam more and more. What remains in the sunlight, traveling straight toward our eyes, becomes richer in longer wavelengths, reds, oranges, and yellows. That is why the sun itself can look golden, orange, or even deep red near the horizon, and why the landscape around us becomes warmed by the same tones. A sunset, then, is not the sky randomly changing mood, it is the atmosphere sorting sunlight by distance. And yet no two sunsets are exactly alike. Some evenings glow in soft gold, some explode into crimson and orange, some develop purples and pinks that seem almost unreal, some fade quickly into gray. Why? Because the atmosphere is never exactly the same from one day to the next. Clouds add another layer of complexity. A cloud is made of countless tiny water droplets or ice crystals. Because the particles are much longer than air molecules, they scatter visible light in a broader, more even way. That is why clouds often appear white when they are lit strongly from above. They are sending many wavelengths toward us together. But clouds can also appear gray or dark. That happens when they are thick enough to block or reduce the amount of sunlight passing through them. The bottom of a dense cloud may receive less direct light, making it look darker from below. In storm conditions, towering clouds can become dramatic structures of light and shadow, reflecting some wavelengths while hiding others, turning part of the sky nearly black while edges glow silver or gold. At sunset, clouds can become extraordinary because they are not always being lit from the same angle as the ground below. High clouds may still catch sunlight long after the sun has dropped below the horizon for an observer on the surface. This can create luminous pinks, fiery oranges, and soft purples suspended above the darkening world. The sky becomes layered in time as well as color. Some parts already in shadow, others still illuminated by the day. And then there is twilight, the slow transition after sunset, when the sun is below the horizon but the atmosphere is still scattering light. Twilight is a reminder that day and night are not an instant switch. The atmosphere extends the presence of sun beyond direct visibly. Even when the sun is no longer seen, its light continues to interact with upper atmosphere, creating afterglow, blue hour, soft gardens, and fading bands of the color. Photographers love the golden hour and the blue hour because they are moments when sunlight is softened, stretched, and transformed by the atmosphere, and as something more emotional. Dimensional, more structure, and often more emotional. Warm low-angle light gives shape to the landscape that faces. The cooler tones of the sunset create calm, distance, and mood. These effects are not artistic accidents. They're atmospheric physics made beautiful. All of this reminds us of something important. The sky is not just a color, it is a record of conditions. A pale sky can tell one story, a saturated blue tells another, a copper sunset tells another, a bright white cloud on a dark blue field suggests one balance of moisture and air, a milky hazy horizon suggests another. We may not always know the science in details, but we sense the changes instinctively because the sky communicates physically and emotionally at the same time. That may be one reason humans have always attached meaning to the sky. We read weather in it, we find direction in it, we mark seasons by it, we notice hope, dread, calm, and change in its color long before we explain them scientifically. The sign does not erase that feeling. It depends. It tells it that what moves it emotionally is often grounded in real dynamic processes unfolding in the atmosphere. The red of sunsets is not separated from the blue of noon. It is born from the same system. The atmosphere that scattered short wavelengths across the daytime sky also removes many of them from the direct path of low-angle sunlight, leaving warm colors to dominate. Daylight and evening are two faces of the same interaction. And when the sun finally sinks far enough below the horizon, even those remaining colors fade. The last gold becomes ash blue, the last pink dissolved, the bright sky withdraws, the atmosphere gives up the day. Now, another question arrives. If the blue sky exists because sunlight is scattered through the atmosphere, what happens when the sun is gone? Why does the sky darken? Why is space black? And what are we really seeing when night begins? Night does not arrive because the sky turns off. It arrives because Earth turns. It is easy to see, say, and easy to forget. We often experience sunrise and sunset as though the sun is moving around us, climbing and singing across the day. But in reality, it is Earth rotating, carrying us into and out of the sun's light. The blue sky of daytime is possible because sunlight is entering the atmosphere and being scattered toward our eyes. When our part of Earth rotates away from direct sunlight, the scattering fades and the sky darkens. At first, it does not become black all at once. Twilight lingers because sunlight still reaches higher parts of the atmosphere even when the sun itself had dropped below the horizon. That light continues to scatter, creating gentle guardians of blue, purple, and fading gold. The upper sky may darken first while the horizon still grows. The upper sky, for a brief time, the atmosphere holds the memory of the day. Then slowly the darkness depends on what appears in another kind of truth. The night sky is not empty, it only seemed empty because daylight is so overwhelming. During the day, sunlight scattered by the atmosphere is so bright that faint celestial objects are hidden from view. At night, when that brightness disappears, stars emerge, planets become visible, and the moon takes shapes, and the dark background of space reclaims the sky. Space is black, not because there is no light in it, but because there is very little matter, there is no scattered light into our eyes. This is the same principle we encountered earlier. Without an atmosphere, sunlight can illuminate an object directly, but the sky itself away from the sun remains dark. Astronauts in space may be in full sunlight while looking into a black sky. The brightness of the sun and the darkness of space can exist side by side because scattering is absent or greatly reduced. Moonlight, too, is part of the story. The moon does not shine by its own visible light. It reflects sunlight. Its phases change because of the relative poisoning of the sun, earth, and moon. And when the moon is bright, it can wash the night sky in silver tones, softening darkness and hiding fainter stars. Even in darkness, the sky remains a place where sunlight is being redistributed, reflected, and filtered. There are also nights when the atmosphere creates phenomena even more extraordinary than the blue of day. The aurora, for example, appears when charged particles from sun interact with gases in Earth's upper atmosphere, causing them to glow in shifting currents of green, red, and violet light. Here again, the sky is not a blank backdrop, it is an active medium. It responds not only to the sunlight, but also to the broader energy environment of the planet and the sun. Sometimes, even without aurora, the atmosphere glows plainly on its own in a phenomenon known as air glow, a subtle emission caused by chemical processes high above us. Most of us never notice it with the naked eye under ordinary conditions, but it reminds us that the atmosphere is never truly passive. Day or night, visible or invisible, it is always participating in the story of light. And then there is the emotional difference between day sky and night sky. The blue sky of days makes Earth feel enclosed, protected, and illuminated. The night sky does the opposite. It opens depth, it reveals skill, it reminds us that beyond that atmosphere lies an almost incomprehensible vastness. Day makes us feel under a world, night makes us feel inside a universe. Yet both experiences depend on the same thin layer of air. By day, that layer fills with scattered blue. By night, it becomes transparent enough for us to see through it into darkness and stars. The atmosphere is like a curtain that can either glow or disappear depending on the angle present of sunlight. This is why the transition from day and night feels so profound. It is not only a shift in brightness, it is a shift in what we atmosphere allows us to perceive. On movement, it is displaying its own scattered light. The next, it is revealing what lies beyond it. And that leads us toward the deepest meaning of the original question, why is the sky blue? Because we live on a planet with a specific kind of atmosphere, under a specific kind of star, where I tend to a specific part of the spectrum. In a place where light and air are constantly shaping one another, blue is not just a color we happen to see, it is the signature of our situation in the universe, which makes the final truth even more moving. What seems ordinary overhead is actually rare, fragile, and planetary. At the beginning, the question seemed almost dreamlike. Why is the sky blue? Now, after following sunlight from the sun, through space, and the atmosphere, across molecules, through the eyes, and into human perception, the question feels larger than it first appeared, because the answer is not just about color, it is about relationship. The blue sky exists because sunlight and atmosphere meet in exactly the right way for human beings to see that color spread above them. Change the atmosphere and the sky changes. Remove it and the blue disappears. Alter the particles in the air and the quality of blue changes. Shift in the sun's angle and the gold and red emerge. Let Earth rotate away from the light and the atmosphere becomes transparent to darkness and stars. In other words, the sky is not a fixed object, it is a living result that makes Earth feel both beautiful and delicate. From the ground, the sky seems endless. From orbit, the atmosphere appears astonishingly thin, a narrow luminous edge around the planets, more like a membrane than a vast ocean. All weather, all breathable air, all the scattering that gives us a blue day and a red sunset happens inside that thin shell. Life depends on it, vision depends on it, climate depends on it, the everyday beauty of the world depends on it. When we say the sky is blue, we are really saying that Earth is wrapped in light, sensitive air, and that is not something every world has. On the moon, the sky is black even in daytime because There is almost no atmosphere to scatter sunlight. On Mars, fine dust and a different atmospheric environment create a sky that often looks butterscotch or reddish by day, with sunsets that can take on bluish tones near the sun. Other worlds would produce other skies shaped by their own chemistry, pressure, particles, and stars. What we call normal is only normal here. Earth's blue sky is local, planetary, specific. It is sunlight that has traveled across space from a star. It is air made of ancient planetary chemistry. It is molecular, scattering happen at scales too small to see. It is the design of human eyesight interpreting a spectrum. It is weather, climate, cleanness, moisture, and angle. It is noon, and it is also the promise of sunset. It is Earth announcing itself. There is also a quieter lesson in this. The atmosphere that makes the blue sky is not invulnerable. Smoke, pollution, excess particles, and changing climate patterns can alter the character of the sky we see. Some changes are temporary, some are seasonal, some are tied to broader environmental systems shaped by human activity. To notice the sky carefully is, in a small way, to notice the condition of the world that can sustain it. The sky is beautiful, but it is also diagnostic. It tells us when the air is clearer. It tells us when particles hang heavy. It tells us when moisture gathers. It tells us when the storms build. It tells us when the day is clean enough to become an almost impossible blue. If we learn to read it, the sky stops being passive scenery and becomes one of the oldest forms of information we have. And still, after all of that, it remains something more than data. There is a reason people stop for sunset even when they already know the science. There is a reason children still point upward with rainbows. There's a reason the first clear day after long rain can feel emotionally different. The atmosphere is not only changing light, it is changing how the world feels to us. That may be the deepest answer for all. The sky is blue because the universe reaches out through matter, and our minds turn that interaction into experience. Physics becomes perception. Perception becomes meaning. Meaning becomes memory. So the next time you step outside on a clear day, look up for a second longer than usual, and remember that above you is not emptiness. It is light melting air. It is thin blue miracle.